In this problem, we're trying to determine the speed of each car after the trigger between them sends them both in opposite directions. We do not know the speed of either car, so we're looking for V1 and we're looking for V2. Okay, in order to do this, we cannot simply do momentum conservation. We don't have enough information. So we need to do a combination of both energy conservation and momentum conservation. In this case, it tells us how much total kinetic energy will be added to the two cars by the compressed spring. So in this particular example, it tells us we will be adding 7.56 joules of energy. So what we want to do is 1/2 the mass of car 1, which would be 580 grams. Obviously, we want to work that in kilograms, times the velocity of car 1 after they separate, squared, plus 1/2 the mass of car 2. Car 2 is 500 grams plus another 987 grams. Again, make sure you work it in kilograms. V2 squared. That's going to be equal to 7.56. Now, we do not have enough information to solve this problem. We don't know V1 and we don't know V2. That's where momentum conservation comes in. Before separation, the two objects have no total momentum. So after the collision, their total momentum again must be 0. This is achieved because one object is going to move to the right, the other object is going to move to the left. So they will have equal but opposite momentums. Okay, this equation also is unsolvable because we don't know V1 and we don't know V2. So rearrange this equation so that it is solved for V1 in terms of V2. Take that expression that you get for V1 and plug it in to this equation to eliminate the variable V1. You will now have an expression that depends solely on the velocity 2. You should be able to solve and get an answer for the velocity of car 2. Once you have that velocity, you could plug it back in to your momentum equation and solve for the velocity of car 1. So it's a lot of work, but if you're careful with your algebra, you should be able to determine the speed of car 1 and car 2 after separation based on the amount of total energy that the two cars possess.